Hello students, we'll move on to the next derivation, that is shape function for 1D cubic element. So till now we have studied one-dimensional linear element, one-dimensional quadratic element, and the next we'll move on to one-dimensional cubic element, or it is nothing but four-noded bar element. So please remember, in the exam he might ask to derive the shape function of a four-noded bar element or a cubic element. So either way you have to write this derivation. So since it's a cubic element or it is a four-noded bar element, the element should have four nodes, that is 1, 2, 3, 4. So here I have written -1 it is in the natural coordinates, it is in the zeta coordinate system. So it varies from -1 to +1, and zeta 3 and zeta 4, that is in between nodes, I have written as -1/3 and +1/3. So how did I get that? To understand that, so for example, if I have an element, so this is an element, so if I divide it into three parts, so if I divide the one element into three parts, so that is, this is 1, so this is 1, this is 2, and this is 3. So I have divided it into three parts. So once I divide it into three parts, I'll get four nodes, 1, 2, 3, 4. Okay, so that's why here zeta 1 is equals to -1, zeta 2 is equals to +1, and zeta 3 is equals to, so this is -1, so it is -1/3. 0 will be somewhere here, and zeta 4 is equals to +1/3. Is this clear? Or in the difference, if you take this, the difference between this and this will be 2/3, this is 2/3, and this is 2/3. So adding all these three, you will get -1 to +1, that is -1 to 0 to +1, which is nothing but 2. So if you add all these three, you will again get 2. Okay, so just understand -1/3 and +1/3. How did you get? Because we are dividing an element into three parts, 1, 2, 3. Okay, so we'll move on to the derivation. 1 and 2 are the primary nodes, 1 and 2 are the primary nodes, 3 and 4 are the secondary nodes, or an higher order. Okay, consider a 1D cubic element or a four-noded bar in natural coordinate system as shown in natural coordinate system, that is in the zeta coordinate system. To derive shape function, consider the Lagrangian function or the Lagrangian polynomial. So this is general expression we have. Ni of zeta is equals to pi, j is equals to 0 to n, I should not be equals to j. Zeta minus zeta j divided by zeta I minus zeta j. Okay. So for I is equals to 1, that is for node 1. For I is equals to 1, that is for node 1. N1 is equals to. So what did I say in the last derivation? When you are writing for the first node, in the numerator, you just skip the first term. That is, zeta minus zeta 1 will not be there. Zeta minus zeta 1 will not be there. So you will have zeta minus zeta 2, zeta minus zeta 3, zeta minus zeta 4. Similarly, in the denominator, zeta I minus zeta j. So what is I? I is 1. So zeta 1, zeta 1, zeta 1, because I is 1. And the second term will be same as the top term, because j and j. Okay. So zeta 2, zeta 2, zeta 3, zeta 3, zeta 4, zeta 4. Is this clear? Very simple way to understand or remember it. Okay. So next, substitute the zeta values here, similar to the previous derivation. So substitute zeta 2 value, zeta 1 value, and zeta 3 value. So zeta 2 is +1, so here it becomes -1, and zeta 3 is -1/3. Substitute that, it becomes +1/3, and zeta 4 is +1/3. Substitute that, it will become -1/3. Similarly, substitute all the values in the denominator. So simplify it, you will have zeta minus 1 into, this is 3 zeta plus 1/3 into 3 zeta minus 1/3. In the denominator you have -2 minus 2/3, this and this will give -4/3. further simplification of this will give you minus 16 by 9 in the denominator, and in the numerator zeta minus 1, and this is in the form of a plus b into a minus b, that is zeta plus 1 by 3 and zeta minus 1 by 3. So it becomes a square minus b square. Okay, so if this comes to the numerator, it becomes minus 9 by 16. 16 by 9 becomes minus 9 by 16. Zeta minus 1 into zeta square minus 1 by 9. That is 1 by 3 square is 1 by 9. Got it? Similarly, move for node 2. That is for I is equals to adjusting my camera. Okay. To see it? Yeah. Now it is fine. So for I is equals to 2. N2 is equals to. So I said when you're writing for the second term, just skip the second term here. That is zeta 2 term. So here I'll have zeta minus zeta 1. Zeta minus zeta 2 is not there because if I write zeta minus zeta 2, j will be equals to I. So zeta minus zeta 1, zeta minus zeta 3 and zeta minus zeta 4. Similarly, in the denominator you have zeta I, which is nothing but 2. So zeta I minus zeta j, j is 1 here. So zeta 2 minus zeta 1, zeta 2 minus zeta 3, zeta 2 minus zeta 4. Now substitute the values, substitute all these values, substitute zeta 1, zeta 2, zeta 3 and zeta 4 values in the next equation, similar to the previous one, how you did it. So substitute the zeta 1 value, zeta 3 value and zeta 4 value. Again you will arrive at this equation. Then you will have zeta plus 1 into zeta square, that is a plus b into a minus b, that is a square minus b square. And in the denominator again you will arrive at 16 by 9. Instead of negative you will have positive here. See this, when it comes to the numerator, it becomes 9 by 16 into zeta plus 1 into zeta square minus 1 by 9. So just remember the difference. N1 is minus 9 by 16 followed by the same equation. Here it is minus, sorry. And N2 is plus 9 by 16 followed by the equation. Okay. So next we'll move on to N3 for I is equals to 3. For I is equals to 3. N3 is equals to. So for when you're writing for the node 3, what you have to do, you have to skip the third term in the numerator, that is zeta minus zeta 1, zeta minus zeta 2, zeta minus zeta 3 will not be there, and zeta minus zeta 4 you have. Understood? So in the denominator, zeta I minus zeta j. I is 3 here. So zeta 3, zeta 3, zeta 3, that is zeta I. Next is j. J is, that is similar to the top. So zeta 1 here, so zeta 1, zeta 2 here, zeta 2, zeta 4 here, zeta 4. Now substitute all the zeta values, zeta 1, zeta 3 and zeta 4 values here like you did in the previous expression. So zeta minus 1, zeta plus 1, zeta minus 1 by 3 because zeta 4 is 1 by 3. Similarly in the denominator, please substitute it. Now here, this two terms is in the form of a minus b and a plus b. So here you have a square minus b square. And this term you write as it is. Denominator, you simplify it. When you simplify the denominator, you will have 27 by 16. So here you will get 16 by 27. That when it comes to the numerator, it becomes 27 by 16 into zeta square minus 1 into zeta minus 1 by 3. Now coming on for fourth node, for I is equals to 4. N4 is equals to, because I is 4. So here what you have to do, in the numerator, skip the fourth term. So rest all the 3 terms will be there. That is, rest all the 3 nodes will be there. Zeta minus zeta 1, zeta minus zeta 2, zeta minus zeta 3. 4 will not be there because if I write 4 for the fourth node, j will be equals to I, which does not satisfy the equation. So similarly in the denominator, zeta I minus zeta j. So zeta I, that is 4, zeta 4, zeta 4, zeta 4. And j is 1, zeta 1, zeta 1, zeta 2, zeta 2, zeta 3, zeta 3 for that particular nodes. Okay. So substitute zeta 1, zeta 2, zeta 3 and zeta 4 values in the next equation, similar how you did in the previous one. So substituting this, again you'll have this, and this is j plus b into a minus b, so zeta square minus 1, this term here. So we'll understand the variation of shape function for a 1D cubic element, that is 4 noded bar element. So here we have 4 nodes, that is 1, 2, 3 and 4. So when you're writing for node 1, so we have 4 nodes, 1, 2, 3 and 4, because 1, 2, 3, 4. So according to the properties of the shape function, what we have when you're writing for node 1, at node 1 it is maximum, that is n1 is equals to 1, and at all the other nodes it is 0. So just draw a smooth curve at all the other nodes to 0. So it is 0 here, continue that curve, 0 here, and continue that curve, it is 0. Understood? So that's what it is written here at node 1. When you're writing for node 1, at that particular node it is maximum, and at all the other nodes it is 0. Similarly, when you're writing for the node 2, at that particular node it is maximum, that is n2 is equals to 1, and at the other nodes it is 0, 0, 0, 0. Just draw a smooth curve. Similarly, when you're writing for the node 3, at that node it is 1, and at all the other nodes it is 0. Okay. Similarly, when you are writing for node 4, at n4 it is 1, and at all the other nodes it is 0. Is this clear? So this completes the derivation of Lagrangian polynomial function. So we have so all these 4 derivations are very important.